In some cases, rectangles are either an overestimation of the area under a function or an underestimation of that area. The mean value theorem for integrals states that if the function f is continuous in the closed interval ab, then there is a rectangle known as the mean value rectangle whose area is equal to the area under the function. This side represents the area of the rectangle. The point where the rectangle and the function intersect is the c, and that height is f of c. F of c is the height of the rectangle times b minus a, which is the width, gives you the area of the rectangle. This side, the integral, represents the area from the function to the x-axis. The f of c is also known as the average value of that function. Another way to write this formula is by dividing the b minus a to this side, making it 1 over b minus a times that integral equals f of c. We can write it this way to isolate the f of c because most times the problems are going to be asking for this, the average value of the function. This is an example of a problem you may be asked. What is the average value of the function f of x equals 2x plus 7 over x squared plus 7x plus 2 on the interval 0 to 1? Well, you have to use your formula. Remember that the average value is f of c. So make f of c equal to 1 over b minus a, which in this case are 0 and 1, times the integral of the function that they give you from those same limits, a to b, 0 to 1. Okay, so this part, 1 minus 0 is 1, 1 over 1 is just 1, so I didn't write that part. To solve for this part, I'm going to use u substitution, making the denominator my u. And the derivative of this would be 2x plus 7, which is the numerator that they give me. So I can rewrite this part as 1 over u. However, I can't use the same limits because now it's in terms of u. So to change them, you substitute these into this equation. So when you substitute 0 for the x, you get 2, which becomes your new lower limit. When you substitute 1 for the x, you get 10, which becomes the new upper limit. Okay, so we know that the antiderivative of 1 over u equals natural log of u. And we still have our limits, 10, 2. So the fundamental theorem of calculus tells us to substitute the upper limit, which gives us natural log of 10, and then subtract that by when you substitute the lower limit, which gives us natural log of 2. And when we subtract this, we get natural log of 5, which is our answer. So this means that natural log of 5 is the average value of this function on this interval. Okay guys, well I hope you understood, and if you didn't, keep trying. Bye!